This is the question from 2024 FRQ questions from AP Physics. So this question says that a block of mass m is released from rest at point A. So this is the point A, and from here the u is equals to 0. The height 6r above the horizontal. So this height is 6r. After being released, the block slides down the track as shown. When released from a point A, the block does not lose contact with the track at any point. The points B and C are located at the highest points of their respective circular loops, both of radius r. So there is loop and this object is able to pass them. All frictional forces are negligible. So now we have to draw the graphs. Okay. Diagram A shows an energy bar chart that represents the gravitational potential energy of the block Earth system and kinetic energy K of the block at point A when the block is released from rest at 6r. So you understand that here the distance was 6r and block was here, and after that there was 2r. So block has reached here. Draw shaded region in diagram B that represents gravitational potential energy Ug and kinetic energy K of the block Earth system, and the block is located at point B. Okay, so we have to draw it according to this. So first of all, understand that at the initial stage, this object has only potential energy and kinetic energy at that time is 0. So what is the kinetic potential energy? mgh. So mg and h, what is the height? 6r. So this is the potential energy that it has, and when it will be at this position, how much potential energy it will have? It will have potential energy and kinetic energy both. So how much potential energy it will have? It will have mg into height, that is 2r. So here it has 6 mgr, here it has 2 mgr. So we can say like this: 1, 2, 3, 4, 5, 6. So at 6 it has 6 mgr. So here it will have 2 mgr, so we can draw like this, because we have to go according to the graph, that is diagram A. For kinetic energy, we can directly subtract it because the total energy will be conserved. So if total energy is 6 and the potential here is 2, we are left with 4. So 2, 3, 4. This will be the kinetic energy. So this will be the graph. So that's the A part. Now the B. Starting with conservation of energy, drive an expression for the speed of the block at point B. Express your answer in terms of r and physical constants. Okay, so now we need to calculate the velocity. Where? At this 2r position, at this is 6r. From 6r to 2r. So we need to now calculate the velocity here. Okay, so see, potential, the energy conservation says that total energy 1 will be equals to total energy 2. So here we have only potential energy, that is mgh. H is 6r. So here there will be two energies, potential energy and kinetic energy. Potential energy will be mg2r plus half mv square, which is the kinetic energy. So this will go on the other side, it will become 4 mgr. 6 minus 2 is 4, equals to half mv square. With m and m goes off, this will multiply here, 8gr equals to v square. So v will be root of 8gr. So this will be the speed at point. Now the C part. On the following dot that appears the block, draw and label the forces that are exerted on the block at an instant that block slides through the point C. Okay, so we have to draw the free body diagram. Like this object has now gone like this. So this point is C for this point. See here, first of all, there will be weight that will be downwards, and being it's in an inverted position, there will be normal. So normal will be also downwards. So there will be two forces that both will be in the downward direction. Then the second part is a student claims that 4r is the minimum height of a point A. So now this was the point A from where it was starting. Earlier it was 6r given, but the student say no, it is 4r such that the block can slide through point C. Point C was like this. This was also 4r without losing contact with the track. Okay, so basically, see, if these both heights are same, so what will happen? The potential energy here will be mgh, which is equals to mg4r, which will be equal to the potential energy plus kinetic energy at point C, and potential energy at point C will be mg4r. It means that the kinetic energy at C will become 0. So kinetic energy at C will become 0. So if the kinetic energy here will be 0, it means that half mv square is 0 and velocity is 0. So if the velocity will be 0, this object will revolve like this and it will end like this. So it will just come down. It will not go with the proper loop. So the student's claim is incorrect. So this is how we have to solve all these questions. So I think that your doubt has been cleared and this video would be helpful to you. Thank you for watching. If you still have some doubts, you can put it into the comment section.